Hello students, welcome to my channel Physics by Physics. Today we are going to discuss about the new chapter Oscillation. Oscillation is a branch of physics which deals with the study of vibrating particles and oscillatory motion and oscillations. Okay, finally in this chapter we will learn about oscillatory motion. Oscillatory motion or oscillations. Okay, first of all, what is meant by periodic motion? So for example, if any body, any motion which repeats itself at regular intervals of time taken, okay, that is called periodic motion. So any motion which repeats itself at regular intervals of time taken, okay, that is known as periodic motion. The periodic means the fixed interval of time taken. Simply say that fixed interval of time taken. Some motion means moving the object, student. And next, if your body moves, okay, in this like a simple pendulum example, a metallic bob is released from the point A to reach point C, passing through B, and B is the mean position, and A and C are point A and point C are extreme position. Any body, if a body moves back and forth repeatedly about its mean position, then it is said to be oscillatory motion. The oscillatory motion is defined as if a body moves back and forth, a to and fro motion, student, back and forth repeatedly about its mean position, then it is called oscillatory motion. For example, okay, in this diagram, the to and fro movement of the pendulum, and jumping on a trampoline, a child swinging on a swing. The examples of oscillatory motion, student. The examples of oscillatory motion. A child swinging. On a swing. The to and fro movement of pendulum. pendulum. And oscillations can be defined as a periodic to and fro motion which repeat itself at regular intervals of time taken. At regular interval of time taken, oscillations can be defined as oscillations can be defined as periodic to and fro motion, back and forth motion which repeat itself at regular intervals of time. Okay, this is the difference between periodic and oscillatory motion. Next to discuss about oscillatory motion and oscillatory motion versus periodic motion. In this oscillatory motion and periodic motion, very simple concept. Oscillatory. Every oscillatory motion is a periodic motion. Every oscillatory motion is a periodic motion. Every oscillatory motion is a periodic motion. That is, every oscillatory motion repeats itself after the fixed interval of time taken. But every periodic motion is not oscillatory. Every periodic motion is not oscillatory. For example, students, motion of planets. Motion of planets around the sun is periodic but is not oscillatory motion. The periodic motion is the fixed interval of time taken, but not in oscillatory motion. The periodic means certain fixed interval of time taken, but oscillatory means to and fro motion about its mean position. Okay, that is the difference between oscillatory versus periodic motion. The next to discuss about some basic concepts of oscillations. The first one is equilibrium position. Equilibrium position. In this equilibrium position, Okay, in this diagram, A and C are A and C are extreme position and B is the mean position. Oscillating bodies comes to rest at their equilibrium positions when a bob, okay, in this diagram, when a bob is suspended from a rigid support, it goes to extreme position and then comes to its mean position, which is also known as equilibrium position. But in this diagram, the metallic bob, okay, this is the bob, the metallic bob is released from extreme ends. The bob is moving, passing through B to reach point C and back to its mean position. Okay, that position is called equilibrium position. The equilibrium position is that position. The equilibrium position is that position where an object tends to come to rest when no external force is applied. When no external force is applied. Okay, in this diagram, in that the bob is suspended from a rigid support. Okay, this is the rigid support, students. Rigid support or point of suspension. When a metallic bob is released from extreme position towards mean position, finally reach extreme position and back to its mean position. Okay, that position is called equilibrium. Equilibrium means the constant position, and to and fro motion of the pendulum oscillating from its mean position B is the mean position, to its either extreme position A and C respectively. Okay, this is the equilibrium position. But next, students, the next one, second one, basic concept, period. The time taken by an oscillating body to complete one cycle of oscillations. This means the to and fro motion of the body gets repeated after fixed interval of time. Okay, it is called period. Okay, in this diagram, so like the period means, okay, this is the suspended point of suspension. So point B, point A, point C. The time taken by an oscillating body to complete one cycle one cycle of oscillation, one cycle of oscillation. Okay, this means the to and fro, the to and fro motion of the body, motion of the body gets repeated after fixed interval of time, fixed interval of time. Okay, that is called a period. Okay, in this the time taken by an oscillating body to complete one cycle of oscillations. A to is a motion body, B to A and A to B, motion body from B to C and C to B. It is denoted by the symbol T, capital letter T. The unit of the unit is second. The above image diagram describes the motion of the pendulum. It goes from B to A and then back to B from A. A similarity, the motion of the pendulum from B to C and C to B. Okay, this is the period concept. And next, last concept in basic concept. Last one. Third one is frequency. Okay, it is defined as the frequency, the number of cycles per second. The number of cycles per second, that is called frequency. It is denoted by V or F or small letter n. The unit second power minus 1. The special unit Hedge is a scientist name. The relation between period and frequency, the time period and frequency, the frequency V is equal to 1 by T, the reciprocal of the time taken. The V is the number of cycles in 1 second. Therefore, T is equal to 1 second. T is equal to 1 cycle. And one problem discuss, students. On an average, human heart is found to be beat 75 times in a minute. Calculate the frequency and time taken. Okay, this is the problem. On an average, human heart is found to be about 75 times in a minute. Calculate the frequency and time taken. The beat frequency of the beat frequency of heart is equal to 75 cycles per unit time taken. Unit time 1 minute. 75 by 60, that is equal to 1.25 2 pi hertz. The frequency is 1.25 hertz. Therefore, the time period T is equal to 1 by frequency f or n or v. So 1 by 1.25, that is equal to 0.8 second. Okay, this is the answer. Thank you, students.